Chima, and today I'll be solving Leetcode problem 2706 by two chocolates. So for this problem, we're given an integer array prices representing the prices of various chocolates in a store. We're also given a single integer array or a single integer called money that represents the initial amount of money. So for this problem, we must buy exactly two chocolates in such a way that we still have some non-negative leftover money, and we would like to minimize the sum of the prices of the two chocolates we buy. And at the end, we want to return the amount of money we will have left over after buying two chocolates. If there's no way for you or for us to buy two chocolates without ending up in debt, we return money. So money, the initial money. And it says here to note that leftovers must be non-negative. Okay, so one way to look at this problem is that the key thing here is that we're basically trying to find a way to buy two chocolates and have some money left over, right? So that's one thing, and then the second thing is that we'd also like to minimize the sum of the prices of the two chocolates we buy. So to make better sense of that, we basically want to maximize the amount of money we have left over after we buy the two chocolates. That's another way to look at this problem. So we basically want to find the cheapest two chocolates from the list of chocolates that we have to purchase. That's basically what this problem is asking us to solve, right? So a very simple way to do this is we know that if we're trying to find the two cheapest chocolates, right? Why don't we just sort our integer array prices and return the and calculate the price of the first two chocolates in our list, and then see if we have money left over after purchasing those two chocolates, right? So that's a relatively good solution, and it does work. So let's write that solution and then figure out a way to optimize it. So as I said, we want to sort our input, right? And then I'm going to say chocolate purchase equals prices at 0 plus prices 1. So we bind the first two chocolates in our sorted list of chocolates, and then we want to say if money minus chocolate purchase, again 0, and return that, else we just return money, right? So let's just extract this to make a little bit more sense. So money minus chocolate purchase, what does that mean? That means uh, total or leftover money left. So leftover money equals that, right? So if our leftover money is positive, then we want to return our leftover money. If it's not positive, we just return the money that were initially given, right? Because we're going to be in debt. So when we run that, in this case, we got 3. In this case, we got output was 3, expected 0. Greater than or equal to 0, right? So non-negative, 0 is non-negative, so that's my mistake. So if it's greater than or equal to 0, then yeah. Then let's submit this, and this works perfectly fine. So now let's analyze the solution here. So for this solution, we could say the time complexity equals O of n log n, right? The reason being is that sorting our initial list of prices in ascending order using the default or the built-in sorting method. So gives us a logarithmic time complexity. And for this, the space complexity is just going to be O of 1, right? Because we're not using any auxiliary data structures here. Now, see, the question we need to ask ourselves is that could we do anything better here? And the answer is yes, we can actually do something better here,